All right, in 1.9b, we're going to look at what's called a z-score, and it's another way to describe the location in a distribution of one piece of data. A percentile is one way to describe the location of an individual in a distribution of quantitative data. Another way is to give a standardized score, also known as a z-score, for the observed value. The standardized score for an individual value in a distribution tells us how many standard deviations from the mean the z-score falls, and in what direction, above or below. To find the standardized score, you compute, and here's the formula you would use. The value in question subtracted by the mean, and then you divide by the standard deviation of that distribution. So they'll give you 2 out of 3 of those pieces of information, and then you'll solve for the missing one. All right, values larger than the mean have positive z-scores. Values that are smaller than the mean have negative z-scores. So keep that in mind, because if it's less than the mean, it's going to be negative. If it's greater than the mean, it's going to be positive. That's a good indicator if you're doing it right. Now, let's return to the data from Mr. Pryor's first statistics test. Where does Jenny's 86 fall within the distribution? Okay. Her standardized z-score is, so we take the value minus the mean. The value is 86. The mean is 80. And the standard deviation, they told us along the way, was 6.07. Okay, so they gave us some of this information. It didn't state it, but they did. So we subtract, then we divide, and we get 0.99. It is above the mean of 80. Okay, it's above, so it should be positive. That is, Jenny's test score is 0.99 standard deviations above the mean score of the class. Now let's try this ourselves. During the 2014 season, the mean number of wins for Major League Baseball teams was 89, and with a standard deviation of 9.6. So you automatically start spelling this out. The mean was 81, the standard deviation was 9.6. The other piece of information I need is the value, right? So that needs to give us something. Find the standardized score for the Washington Nationals, who won 96 games. That's the value, okay? So to do my formula, remember I do value minus the mean divided by the standard deviation. So my value is 96, subtract the mean, divided by 9.6. Now in your calculators, make sure you do the subtraction part first and then divide by 9.6. Equals 1.56. So obviously 96 is above the mean, so it's positive. So we need to interpret this value. We would say the Washington Nationals number of wins in 2014 is 1.56 standard deviations above the mean of 81 wins. Okay? So that gives you an idea of how you would interpret. Now let's try another one. The Dow Jones Industrial Average is a commonly used index of the overall strength of the U.S. stock market. In 2013, the mean daily average in the Dow Jones for the 252 days that the stock markets were open was 13.59 points, with a standard deviation of 94.05 points. Find and interpret the standardized score for the change in the Dow Jones on May 7th, which was 87.31. So let's decode this a little bit. What was the mean? The mean was 13.59. Standard deviation was 94.05. And the value in part A that we're looking at is 87.31. So to find my z-score, I take my value first, always do the value first, subtract the mean, then divide by the standard deviation. When I do that, I get a z-score of 0.78. Now, it says find and interpret, so we need to interpret this. We would say the change in the Dow Jones Industrial Average on May 7th 2013 was 0.78 standard deviations above the mean of 13.59. Okay, so notice you have context, and you tell me it's so many standard deviations, and you have to tell me above or below the mean. Above because it's positive. If this came out negative, then we would say below the mean. Now, B changes it up a little bit. It says the standardized score on May 1st was a negative 1.62. Find the change in the Dow Jones for that date. Okay, so this changes it up. We need the mean and the standard deviation, and now we gave the z-score, so we have to do a little algebra. So we know our equation is going to equal negative 1.62. The change is what we don't know, so I'm going to put an x in there because we don't know that part. Change minus the mean divided by the standard deviation. All right, now to solve this, I want to get rid of the fraction, so I'm going to multiply both sides by 94.05, whatever's the denominator. And on the right, these two will cancel out, and when I multiply these, I now have 152.36 equals x minus 13.59. So now I can add 13.59 to both sides, and I have what x equals. So when I do that, I get negative 138.77. Now, to interpret this, this is just below. All the negative means is it's below the mean. Okay, so we would say the change in the Dow Jones Industrial Average on May 1st, 2013 was negative 138.7. Okay, remember this part of the problem didn't ask us for a z-score, it asked us for a change. So that's why I use what is the change. Okay? Hopefully this makes sense, and we will talk more about this in class.